Welcome to the Area Between the Curves podcast. This is podcast number 1. I'm going to go through this problem. I do have the work written up here. I don't know if I gave you this one in your notes. Maybe I did. If I don't have the notes handy, I gave them to you. But let's take a look at this one. All right, so we want to find the area of the region bound by two curves, y equals x cubed minus 9x, and y equals 9 minus x squared. And y equals x cubed minus 9x is the purple curve, and y equals 9 minus x squared is the green curve. And notice that the top, which curve is on the top and which curve is on the bottom switch. So if who's on the top and who's on the bottom switch, you're going to have to split a curve into sections to find the area between the curve. So in this problem, we're going to be splitting a curve into sections to find the area between the curve. So notice we have two parts. We have A and B. For part A, x cubed minus 9x is the top curve, and the x squared, 9 minus x squared is the bottom curve. And for part B, they switch. All right, so you just have to make sure you set it up right, top minus bottom, whoever's on the top, whoever's on the bottom. All right, you need to figure out where your points of intersection are. Here we're pretty lucky. They're pretty nicely listed there. But we would just set that equal to set the two parts equal to one another and solve. So let's do that. I'm going to do that in green, so it's in some other color. So I have x cubed minus 9x equals, and then at 9 minus x squared. And so we'll just move everybody over. So we have x cubed plus x squared minus 9x minus 9 equals 0. I hope you see that you could use x squared become a group, and then negative 9x minus 9 become a group. And so you factor out the common factor, so you'd factor out the x squared. So factor out x squared, I've got x plus 1. And if I factor out negative 9, I have an x plus 1 again. And then this factors to x squared minus 9 x plus 1. And you should always solve it algebraically. Don't rely on the graph unless the point is listed on the graph. Because what if my graph's a little off? What if that's negative 0.11, right? And we can't tell, right? So this way, we'll just factor that, and you can see our points of intersection are x equals 3, x equals negative 3, and x equals negative 1. So they switch places at x equals negative 1. Right? So we go from negative 3 to negative 1. We switch the curves, and we go from negative 1 to 3. All right, so let's finish this one. So let's go to the red, A here. Right? You got to follow, I guess. So got to follow along with this one. This one here, number 1 here, is just finding the points of intersection. And then part 2 here is finding our area. And so we found the area of A, we found the area of B, and then we add them together. And I ran out of space, so part 4 is right here where we added them together. All right, so we've got x cubed minus 9x dx from negative 3 to negative 1 minus 9 minus x squared from negative 3 to negative 1. So we integrate, we have x to the 4th divided by 4 minus 9x squared divided by 2 minus 9x minus x cubed divided by 3, all evaluated from negative 3 to negative 1. Don't forget to distribute the negative sign there. And then we're going to plug in the negative 1, and we're going to subtract the negative 3. Right? So be real careful on your signs. That's where you can start to get tricky. So don't try and skip steps, and then you end up messing up your signs. So negative 1 to the 4th power divided by 4 minus 9 times negative 1 squared divided by 2 minus 9 times negative 1 plus negative 1 cubed divided by 3. And then we're subtracting negative 3 to the 4th power divided by 4 minus 9 times negative 3 squared divided by 2 minus 9 times negative 3, and then plus negative 3 cubed divided by 3. So that negative 1 to the 4th power, that's just going to be 1/4, and then we're going to have minus 9 halves plus 9 minus 1/3, and then I just distributed the negative signs. So we have minus 81 to the 4th, and this would be a minus, and then we have a plus, right? So we have a minus in front of that 9, but then we have to distribute the negative, so that becomes a plus 81 halves. And then we would have had a plus 27, but then we have that negative sign, so that becomes a minus 27, and then plus 9. So you add that together, you get 20/3. That's for section A, right? So then we're going to find section B. We just switch them, and we have a different interval of integration. So now we have 9 minus x squared from -1 to the dx from -1 to 3 minus x cubed minus 9x dx from -1 to 3. So we integrate, we have 9x minus x cubed divided by 3 minus x to the 4th divided by 4 plus 9x squared divided by 2, and we're going to plug in 3 and -1. All right, so we plug in the 3 into all of those. We have 9 times 3 minus 3 cubed divided by 3 minus 3 to the 4th divided by 4 plus 9 times 3 squared divided by 2, and then we're subtracting 9 times -1 minus -1 cubed divided by 3 minus -1 to the 4th divided by 4 plus 9 times -1 squared divided by 2. All right, so we simplify that and we distribute that negative. We have 27, we have minus 9, we have minus 81/4, so you can go across and see where we got all these numbers from. We have plus 81 halves, and then that would have been a plus 9. We distribute the negative, and that would be a plus a minus 1/3, because it was already a plus, right? Because we have a minus a negative, and then we distribute a negative to it, that becomes a minus. Now we have a plus 1/4, because we're distributing a negative to a negative, and then we have a minus 9 halves. So we add that up, we get 128/3. So we just add up the 20/3 and the 128/3, and 148/3 is the area for those two curves. All right, so that's all there is to this one. All right, so sometimes you have to split it into two parts, and that's fine. If we didn't split it into two parts, we'd be wrong. All right, so here I have all the steps written out for you, really nice. We want to find the area of the region that's enclosed from the curves y equals x squared and y equals x plus 6. And as we go through these, if you have questions, let me know. And I can answer them in class tomorrow. Number one step for us is to graph. There's our graph. You need to have a graph drawn. I'll expect that. And that way you'll set up your problem correctly. Now, if there's already a graph drawn for you, obviously, then you don't have to draw one. Number two, we want to decide which way to integrate. All right, so this should be integrated with respect to x. Right? Our y's are isolated. So when integrating with respect to x, we integrate top minus bottom. Right, and our points of integration go, the right's going to be the upper, the left value is going to be the lower. All right, so number three, to find your points of intersection, you set those two things equal to one another. We've got something squared, so we're going to isolate everything on one side. We've got x squared minus x minus 6 equals 0. That factors to x minus 3 and x plus 2. We have two solutions, 3 and -2. Right, so that's going to be our points of integration. We're going to go from -2 to 3. -2 the lower, 3 is the upper. All right, so our upper is the line, so x plus 6 dx minus the parabola x squared, and we'll integrate. And that's a simple integration. So x squared divided by 2 plus 6x, and then minus x cubed divided by 3, and we're going to evaluate that from 5 to -2. So we set up our integral, we integrated, and now we evaluate. So that's our 6 steps. So we have 3 squared divided by 2 plus 6 times 3 minus 3 cubed divided by 3, and then we're going to subtract -2 squared divided by 2 plus 6 times -2 minus -2 cubed divided by 3. So that becomes 9 halves plus 18 minus 9, and that would be a -2, a plus 12, and a minus 8/3. So I just got a common denominator here so I could add everything. And I added the integers together first and then got a common denominator. So there's an 18, and there's a 12, and there's a -2. So that's going to give me a 19. And then we've just changed the 9 halves to 6. We have 27/6. And if we change the 8/3 to 6, we have 16/6. And 19 is 114/6. And that's going to give us 125/6 as our area between those two curves. Okay? So, you really want to have all your steps and just work carefully, and I think you should get these correct. All right, here's the next one. All right, all solved out pretty nicely here. I had lots of space, so I put all the steps here. If this one's in your notes, it was written incorrectly. It's y equals x minus 2. I think it says negative, I don't know what it says there, x plus 2. But that's clearly wrong. You can see that from the graph. It's supposed to be y equals x minus 2. All right, so we have our graph there. We're going to integrate with respect to y. We can do this as two separate areas, because you see there's a problem if I go with one area, because look what happens right here, like for instance. All right, my bottom curve, well, it's not the line. My top curve is that parabola, sideways parabola, and so is my bottom curve. All right, so from where the line intersects the parabola, that one function there is both the top and the bottom, if you will. All right, so we're going to integrate with respect to y. And I think I've got a2 solved there. And then we'll do a1. And oh, I see the problem. I'm sorry. I looked too quickly. We're isolated for x nice and easily. However, we're going to have that one is a problem. If we go sideways, though, we won't have the problem. So actually, I'm sorry. That's why I have the two pictures up here. Oh, now pay attention to my own pictures. So we're going sideways, right? Because we're going with respect to y. All right. So this one here shows why we would integrate with respect to y. On this one, I have a right and wrong picture. So we want to integrate with respect to y, because now, you see, we go left to right. It's fine, right? Because our line is on the left-hand side and the parabola is on the right. Excuse me, I was not paying attention very carefully. And then on this one, we would have a problem. This is what it looks like if we would integrate with respect to x. And anyway, this is a problem here because we have to write two equations here. We don't really want to do this. All right, that's where we would have the up and down curves, and we go top to bottom. We don't want this because that becomes a problem there. All right, so this here is a no. So let's cross that out so we don't get confused, because we're doing this. So we're going left to right. I keep doing that. Right to left, high to low. Right? So right to left. So the line is on the right, and then the parabola is on the left. So we have y squared equals y plus 2 to find our points of integration. All right, so we just move the y over and move the 2 over. They're going to become the opposites, and that will factor. Y minus 2 times y plus 1. So 2 and negative 1 are our values. And they're the y values because we're solving for y. All right, so that's going to be our 2 points of our 2 boundaries of integration there. Right, so top goes, it's right minus left, and then our values are top minus bottom. All right, so when we integrate, we've got y plus 2 dy from negative 1 to 2 minus y squared dy, and this should have the negative 1 to 2 as well, because I should have written in blue since I'm writing in blue. So we integrate, nice easy integration there, y squared divided by 2 plus 2y minus y cubed divided by 3. Then we just plug in our value. So we'll plug in the 2, and then we'll plug in the negative 1 and subtract. All right, so we have 2 squared divided by 2 plus 2 times 2 minus 2 cubed divided by 3. And then we want to subtract off the parts we don't want so that we have just exactly what we do want, that area between the curve. So we're going to have negative 1 squared divided by 2 plus 2 times negative 1 minus negative 1 cubed divided by 3, and we simplify. So we'll have 2 plus 4 minus 8/3 minus 1/2 plus 2 minus 1/3. So we can combine the 2, the 4, and the 2. That comes 8. The negative 8/3 and negative 1/3 becomes negative 9/3. That's just 3. So we have 8 minus 3 is 5, minus 1/2 is 4.5. So that's the area between our curves. All right, so sorry, I have a right and wrong picture here, and I started to look at the wrong picture first. You think I'd look at the right picture first. All right, but all the steps I think are laid out here pretty clearly. And this is just kind of showing you why you want to, this is integration with respect to x, and you don't want to do that in this problem. You want to integrate with respect to y. First of all, it's easily solved for x. All right, granted the first equation's not, or second equation's not, the y equals x minus 2. But if you just add 2 to both sides, voila, x equals y plus 2. There you go. And then all of your bars have no problem. It's going to be the line minus the parabola, because you don't want the parabola minus parabola. All right, here I've sketched it. So when I say you need to draw a graph, it's just to represent the situation. This is as detailed as you technically really need to be. All right, not like curve sketching where you need to be very precise. This is fine because we're just looking to see which curve is where do these intersect, which one is to the right, to the left, top, bottom, which way should I integrate. All right, so here we're going to integrate with respect to x. It's already solved out for y. We've got, it works out very nicely to go from top to bottom. All right, so top minus bottom, and then our boundaries are going to be the left boundary and the right boundary. To find those boundaries in step 3, you set them equal to one another. So these are the steps that I expect when you're solving these out. Just like this. This would be a perfect example of what you should do. So we have x squared equals the square root of x. Square both sides. So now we have x to the 4th equals x. Move all the terms to one side so you can factor x to the 4th minus x equals 1. So we have x times x cubed minus 1 equals 0. So x equals 0 is 1, but that's technically outside the boundary. So that's what it means by outside the boundary. Let's read our question very carefully. And then let me look at the other point of intersection, and then we're going to talk about where our boundaries are. X cubed minus 1 equals 0. X cubed is 1. So make sure you know where your boundaries are, because we're enclosed by these two vertical lines, which is why there's two blue vertical lines there. We have x equals negative 1/4, and we have here x equals 1, because those are our boundaries. So where they intersect isn't going to matter, because we're not going to use that one. So we're just using, maybe I'll try to outline it in purple here. Let's see how well I can do. So we're just finding that purple area right there, and it's sort of okay. There we go. We're finding that purple area right there. So we've got the green on top. We have the red, which is the y equals the square root of x, which makes sense. If you use really small values, the square root's going to be bigger than the number you're taking square root of. And then the equation on the bottom is y equals x squared. So we're going to have the square root of x minus x squared. And since 0 is outside the boundaries, we're just going to go between those lines, 1/4 and 1. Right? So we have one point of intersection on the boundary, and the other boundary is going to be our other point of boundary point. Couldn't think of what I wanted to say. All right, so we have the square root of x dx minus x squared dx, and somewhere is missing boundaries here. This is the boundary from the one below it, so this should be a 1 and a 1/4, and I'll squeeze a 1 over here on this one. All right, so we have from 1/4 to 1 square root of x dx minus x squared dx. So a simple integration. We have x, I just changed it to x to the 1/2 dx. And then when we integrate that becomes 2/3 x to the 3/2 minus x cubed divided by 3. We're evaluating it from 1/4 to 1. So we plug in the 1, then we subtract the 1/4. So we have 2/3 times 1 to the 3/2 minus 1/3 cubed minus 2/3 times 1/4 to the 3/2 minus 1/4 cubed divided by 3. So now we're going to simplify that out. That becomes 2/3 minus 1/3, pretty simple there. 2/3 times 1/4 is going to give us negative, and we're subtracting that. It's going to be a negative 1/12. We distribute the negative to the 1/4 cubed divided by 3. That's just really 1/3 times 1/64. And that's going to become 1 over 192. So now we're going to add our terms together. We've got the 2/3 minus the 1/3 plus the, what happened to the 1/3? We've got 2/3 minus 1/12 minus 1 over 192. What happened to the 1/3? I see that nowhere. So maybe this has an error. Now, if I had said 1/3, because I was combining those terms, that'd be fine. So it should be 1/3 minus 1/12 plus 192. So that's going to change this number here. So 3 goes into 192 64 times. So this is going to be 64 192. So that's going to be 65 minus 16, so that's going to be 49. And you can tell me if this isn't right. Now, what did I say? I said 49, not 69. All right, so 49 over 192, that appears correct, because I can't see that 1/3 minus 1/3 seems to have disappeared. Maybe I looked at the plus 1/3, that's the coefficient next to 1/64, decided they canceled each other out for some crazy reason. All right, so that one appears to be correct here. And that thing in the red is just, I think someone last year had a question on how that became 1/12. So 1/4, the square root of 1/4 is 1/2. 1/2 cubed, it becomes 1/8, and 1/8 times 2/3 becomes 1/12, in case you weren't sure. All right, so we've got a little bit of time on this podcast. Let's continue on. All right, so we're going to find the area between the curves in the first quadrant. So it says first quadrant, so now we're not going to go below to the second quadrant. All right, so notice here we have a different lower function. It's not the consistent for the entire region, so we're going to have to switch and split. So it's kind of like the one where we had, the two functions changed places. Now we just have a different function. So for piece 1 there, the upper function is 1/2 square roots of x. The lower function is the line, and the line is y equals x minus 15. For part 2 there, the upper function is still y equals 1/2 x, but the lower function is y equals 0. It's the horizontal line. So when it says first quadrant, it means to stop at the x and y axes. All right, so we've got 3 equations here. We have y equals 1/2 x, we have y equals x minus 15, we have y equals 0, which is the x-axis. So we're going to have to find where our boundaries are, our upper and our lower boundaries, right, for each of our sections here. And we're just going to solve it as 2 separate, and we're going to add them together, kind of like the one where they switch places. Right, so I have some work on the next page. Let's double check here. Yes, we do. All right, so we need to find the boundaries here. Did I ever find the boundaries? I did over there. All right, so in the corner there, we have square root of 1/2 x equals x minus 15. Square both sides. And we're looking for this boundary point here. We're looking for where the line intersects the what are we looking for? Where the line intersects the parabola, but at the top there. All right, so we're looking for that top intersection point. I already have it written in, but we're looking for that one. All right, so we have 1/2 x equals x squared minus 30x plus 225. All right, so now I subtracted 1/2 x from both sides. Quite honestly, before I even did that, I should have just multiplied by 2, because I do that on the next step. We have 2x squared minus 61x plus 450. That does factor. It factors to, well, it sort of factors, 2x minus 25 halves and x minus 18, and we'll take it. The 5 halves, the 2x minus 25 halves is going to be outside the boundaries. It's going to be negative, so that we don't use that one. But we're going to use the other one. So it's where the line intersects the parabola again. But we're going to use x equals 18. So 18 is one boundary. The other one is pretty easy to find. It's just where x minus 15, where the y value is 0. So this would just be 0 equals x minus 15, and well, x equals 15. That's our other boundary. So, and then our third boundary has to be in the first quadrant, is 0, 0. So we're going to evaluate piece 1 here, which I put a blue 1 in, from, we're going to have y equals at 1/2 x is going to be the top function. Y equals 0, or 0 is going to be the bottom function, and that we're going to evaluate that from 0 to 15. And then we're going to switch and do part 2, and so that's going to be the square root of 1/2 x, and then minus x minus 15, the line there, and that's going to be from 15 to 18. All right, so I kind of have it done here with just the answer, but we're going to solve this out. This is a u to u substitution, so a good chance to practice that. Not the line, but the square root, 1/2 square root of x, right? Because we don't just have an x there. So anything like that would be a u to u substitution. U is going to be 1/2 x. That makes du equal to 1/2 dx. Don't have well, we have a 1/2, but it's stuck into the radical, so we don't have a 1/2. So we're going to multiply both sides by 2, and so 2 du equals dx. All right, so that gives us over here, let me try and scroll down a little bit so we can see the rest of this problem. Come on, come on. Good enough. I think I got enough to the board. Oh, it looks like this problem just ends, so we'll just finish solving this out. So we have 2, so we're going to have 2, we're going to pull the 2 out, and then u to the 1/2 to u, right? So, and then minus 0, right? So there's really no reason to write in minus 0, because that's y equals 0, right? You don't need that one. All right, so then we have, and that's divided from 0 to 15, all right? And then from 15 to 18, we have u to the 1/2 du minus, and notice I left the variables of integration out because I did substitute back. I mean, not variables of integration, the boundaries of integration. So I did substitute back for the u, but I didn't need a substitution on the x minus 15. So this is just the square root of 1/2 x, so that's just going to be 2 integral u to the 1/2 du. And then we're going to subtract the line from that second piece. So that's going to be the integral of x minus 15 dx, and that one is simple to integrate. So we integrate 2/3. We'll have the u will increase by 1 the exponent. We divide by 3/2. So that's going to be 2 times 2/3 u to the 3/2 plus, and then the same thing again, 2/3 times 2u to the 3/2. And then to integrate x minus 15, that would become x squared divided by 2 minus 15x. So now I just substituted back we had 1/2 to the x. So I just simplified that, and so I have, hey, wait a second, we seem to be missing, what happened to the 1/2 x? You know, something seems amiss. We're missing a 1/2. Let's do this one over because this one might have an error on it. Oops, and I erased almost too much. Oh well, that's okay. And actually, I'm gonna change these boundaries so I don't have to plug that 1/2 in. Oh, you know what? I'll plug the 1/2 in, and we'll see what it looks like. All right. So this will give us 2 times 2/3 u to the 3/2 plus the same thing, 2 times 2/3 times u to the 3/2 minus, and then x squared divided by 2 minus 15x. And eventually, we'll put back the limits of integration on this part. I mean, yeah, limits of integration. And then oops, come on, Reese. All right, so let's simplify that and we'll plug back. So this is going to be 4/3, and that's the square root of u is 1/2 x. So that's 1/2. Oh, of course. Let's get a typing board where we don't need one. And then don't go away anytime soon. All right. I don't even know how that comes up. So we have, because I didn't hit the key. We have 1/2 x cubed plus, and then again we'd have 4/3, 1/2, all of that, x cubed, and then minus, oh, and that's going to be, this one here is going to be integrated from 15 to 0. All right, and then minus, this would be, this part, all of the rest of this is going to be 15 to 18. So then x squared divided by 2 minus 15x, and that's all evaluated from 15 to 18. And you know, I'm over my 30-minute mark. So I'm going to finish evaluating this, and I'm going to come back with this problem done in the next podcast. Okay? All right, bye for now.